So we are ready. Hi, everyone. Oh, I need to use the... Hi, everyone. So I was lucky that today in the morning I received the visit of several of you with plenty of questions, and it was very interesting. And you guys have now some homework to do, so that I present to you you present a little bit of an advancement of your discrete choice experiment. And again, I keep encouraging anyone who may need to have more advice to come to the office. I guess tomorrow is not going to be the case, but on Thursday or on Friday. Okay. A little bit of the theory behind these models. And we could do a little bit of math, but let's talk about it a little bit more intuitively. The basic theory is called random utility model, random utility theory. And the basic idea behind the theory is that when you are presented, assuming that you are a rational individual, when you are presented to two alternatives and you have to choose one or the other, the one that you choose is the one that is going to give you the most utility from the two options that you are being faced to. In that respect, is that it is, the maximum utility, or the utility that from the two options that you have in front is the one that is going to give you the max. Of course, you are always there is always the chance that both of them give you the same utility. But then if you are forced to choose, you are going to choose randomly, no? You flip the coin. And that's where the randomness comes into the model, starting with the fact that you, as a researcher, don't really know whether people are choosing, in that specific case, just randomly, because the two options give them the same utility. But there is another component of randomness. I, as a researcher, or you as researchers, will only be able to model as much of the utility of the people. But the people are the ones who are going to know, or we are going to assume that they know absolutely everything that matters in terms of their utility. Because we don't observe everything that matters, from the perspective of the researcher, this is a random decision to a certain degree. What do I mean by that? And this has to do with the attribute that you are going to be choosing. When we model econometrically the utility of people, we assume that people obtain utility from the attributes that we are presenting to them in the discrete choice experiment. Let me go back to as you can see, I use a lot of these two examples because I find them intuitive and I find them easy to understand. In this case, when I tell you, please choose between option A, option B, or the current situation, I am assuming, because I did the literature review, because I did the piloting, and then the semi-structured interviews, and then the piloting, and then again the piloting, I am assuming that I have certain understanding of what matters for you in this decision. I know that having green in your neighborhood matters. I know that relocating the parking spaces is going to matter. Whether your facade has or not some green, and whether you reduce the speed lane or not. In this case, I know that the distance that you travel to your workspace matters. Whether you are going to have a parking space for bikes matters, and how much money you pay matters. I am assuming, and I have enough evidence to assume that these are factors that internally matter for you when it comes to taking this decision. The random utility model is going to say, well, the utility of this person increases or decreases based on whether it has to work too much or not, based on whether it has to pay too much or not. And the reason why I'm going back to these examples is because when you run the regressions, and we will see later on, you are going to be including these as the explanatory variables of the decision. People are going to be deciding between one or the other, and you are going to place the variables and say, well, the people are choosing those that have more, that have less to pay. You have to pay less, then you are going to choose more likely that option. But these are not all the factors that matter in the decision. Yesterday we discussed, you are going to start with at least of 20. And then later on you are going to do semi-structured interviews. And later on you are going to have to say, it seems that people really care about 10 attributes, but they are not able to handle 10. So I am going to put these 3, these 4, because I asked them, what are the most important? So to begin with, by design, you are not including every attribute that matters. For those of you who have taken econometrics, where those attributes go? Where do they go? Where? Higher, louder. Error term, right? It goes to the error term. These are unobserved factors that are not modeled, and that therefore go into the error term, and that's where the randomness comes from. This is the random utility model, because you can be certain that if you assume that the person is rational, they will be choosing the option that gives them the most utility based on the observed characteristics, but also based on unobserved characteristics. And because you are not including all characteristics that matter, you are going to have to model the error term. There is some level of randomness from the perspective of the researcher. That's why this is called random utility model. Because you can only assign a probability to the fact that the chosen alternative is the one with the highest utility. Now, here is another econometric question. Yesterday I told you that there is no endogeneity here, right? So, if there are all these characteristics that matter, and that they are in the error term, what is the other definition of endogeneity? Those unobserved factors. The other definition of endogeneity is omitted variables, which are unobserved variables, unobserved factors that matter in the decision when it comes to the observed part. So why is that we don't have endogeneity in this case then, if we have a lot of unobserved variables? How am I sure that there is no endogeneity? There is an observed factors, but they are not provoking omitted variable problems, right? For those of you who already took your course and maybe didn't understand it that well, because to tell you the truth, the first time I took the courses, and then it took me a good number of years to understand what exactly omitted variable was. The omitted variable problem is having unobserved variables is not the problem, right? We always are going to have unobserved variables. The problem is whether there is one variable in the group of unobserved variables that is correlated with the variables in the observed component, right? That is what provokes the endogeneity, because that variable is going to explain or is going to associate the variable in the right-hand side and the variable in the left-hand side. But in this case, what we are fairly assuming is that those variables are out of the equation randomly. We are not systematically leaving a important characteristic of the decision outside of the equation. If you were leaving systematically something outside of the equation, then you will have a problem of endogeneity. But arguably, when you design this, the way you design it, as we explained yesterday, implicitly what we said yesterday, by doing these random allocations and by presenting people randomly the choices that you generate, implicitly what we are saying is that we are randomly not presenting them to the characteristics that we are not including. I hope you follow me. The randomness in the design of the observed characteristics implies randomness in the non-design of the non-observed characteristics. When you are presented to a specific choice set, it's very difficult to think that there is some kind of systematic association that I am leaving out of the equation, as long as I present you randomly to the choice set. That's what I'm trying to say there. Questions about that? Did you follow me? Yeah, that last part. Basically, what I am saying is, yesterday I spent a lot of time, well, I don't know if a lot of time, but I spent some time trying to explain how to design the discrete choice experiments in terms that it is orthogonal or semi-orthogonal. And then I said, when I present to you those choices that I design, I present them to you randomly. Therefore, you cannot pick your price. You cannot endogenously pick your good. Well, the fact that I am presenting you randomly and exogenously with the observed component of your utility, where the observed component are the attributes that I'm presenting to you, it also means that I am presenting you randomly to the unobserved component of your utility. The characteristics, the attributes that are not included here, I am not including here. If for whatever reason you could come out with an storyline where you are telling me, oof, that way that you did this systematically presents wealthier people with more expensive houses, then very likely we have endogeneity. But because when I go to the survey, I don't see your wealth, I don't consider your household size, I don't consider anything when I assign you to my choice set, arguably there is not endogeneity. Despite the fact that we have a good number of unobserved characteristics that we are not considering. Remember? That's how I tried to start. The random utility model assumes that people choose the option that gives them the most utility, but it remains random because, one, we never know when they are choosing from two alternatives that they are indifferent from, and therefore they flip the coin. That is one source of randomness. And the other one is, we don't know many factors that matter in the decision of going to war hybrid, or buying a house, or choosing the greenness of your neighborhood. But because those factors will leave them out randomly or without any systematic variation with observed characteristics, then there is no endogeneity. Yes? Okay. Very good. Let me see what I didn't cover yesterday here. This is endogeneity. Okay, we should be covering everything from yesterday. So today I wanted to start after this with, so yesterday I was working so hard on giving you like this general perspective, policy here, policy there. And then I was working a little bit on the design, and I started with random utility model because I think that the very beginning is a good moment to explain the theory. And then I am going to work with the example that refers to India a little bit. Then Sangeeta is going to help me giving a little bit of the context. Then on Friday, there is going to be even more about applications in India. So why not we let Sangeeta give us a context of how this study matters, how it came to realization, because actually, among other things, she's the one who is the expert on this.
title of this program is about climate change and how preferences lead to policy making. So this is one of the application in terms of mitigation of greenhouse gas emissions. As we know, in India is one of the third largest greenhouse gas emitter, and large amount of greenhouse gases or carbon dioxide is contributed by India, obviously because India is a large country. So one question that we want to grapple with here, that how countries can reduce their emissions. Many countries in the world are taking steps to reduce emissions. India is also one of them. There are all these international negotiations and meetings and conferences where countries commit to reducing their greenhouse gases or emission intensity by a certain percentage. India has also committed to reducing its emission intensity by 45% as compared to 2005 levels, right? So when we make all these commitments, that means that there need to be some domestic action that needs to go, some pathways to be able to meet the target, that we just go in an international negotiation and commit that we are going to do this. But when we come back home, we have to do something, right? So National Commission for Climate Change, that was being set up, and one of the elements of this National Action Plan for Climate Change was setting up of Bureau of Energy Efficiency. The objective of Bureau of Energy Efficiency was to come up with policies so that consumers can use energy more efficiently. Okay, that was the objective. And we know that Bureau of Energy Efficiency has come up with many of these star labeling programs for electrical appliances in India. 10 years back, there were no star labels, but today you want to buy a refrigerator, you want to buy an air conditioner, you want to buy any of the electrical appliances, there are these star labels. What are these star labels telling us? That a 5-star label is most energy efficient. A 4-star label will be energy efficient, but not as much. And a 1 or 2-star is highly energy inefficient, right? So labeling also is one of the ways in which you can impact consumers. Consumers, they of course look at prices, but there are other ways also to communicate to them or deliver them the message. So labeling policy was one of the things that had come up in India, and we were thinking about that, okay, if a similar labeling comes up for cars, because transportation sector is a major contributor to energy. So something needs to be done in the transportation sector. And one of the things that needs to be done here was that suppose people move to more fuel efficient cars. And then the question is that even if such cars are available, is there a demand for them? Do consumers actually value? Will they move to a car which is more fuel efficient? Will they be willing to pay a higher price, and how much higher price? So in yesterday's introduction, I told you that just making technologies available is not enough. People should adopt them. And they're not going to adopt them unless there is a preference for such technologies, unless there is a demand for such technologies. So all these things, and in addition, one more thing that we wanted to look at, because we are in Delhi, we want to see that do people care about air pollution. So car emissions are not only leading to carbon dioxide emissions, but they're also leading to air pollution. And Delhiites, like every winter, even today, we just keep checking what's AQI, it's 100, 200, 300. And of course, there are studies that have provided evidence that this air pollution has not only respiratory problems, but even mortality. So one of my papers, I show that in Delhi we lose 5 years of our life expectancy just because we are inhaling this kind of air. So all these things together, and then we thought about that how do we design an experiment that captures these elements. One more element I wanted to capture in this experiment was that Delhi government started with odd-even schemes. How many of you are aware of the odd-even schemes? Everybody, right? So what's the scheme? That during those days on which pollution is very high, only specific cars will be allowed to ply on roads. So if the date is an even date, 2, 4, 8, 10, 12, then all even number cars will be allowed to be on road, and on odd number dates, odd number plates will be allowed to ply on the road. Now, we have experienced this because it was implemented in Delhi, and we had also experienced, all the hardships that come with it. I have to go, I have to deliver a lecture, I have to be at JNU, but my car number is even. Today is odd date. How do I reach? And there's no market for it. If I just want to, evaluate how do people, what kind of value do they give us? I don't have a market. There's no price for it. And then one has to find out, have some innovative ways in which we can assess how much consumers value these kind of things. And, so Adan will, you will describe the experiment, right? Okay, he'll describe the experiment, but I just want to say that through this experiment, we could compute the cost of the regulation. That how much did this regulation cost to the people, how much inconvenience it cost to the people, and how much they are willing to pay to get rid of it. Yeah, so if you give them a choice that, you'll be exempted from this regulation, how much are they willing to pay for it? And this is, the first of a kind of a study which is trying to find out cost of a regulation. Okay, so he'll explain I don't want to go into the details of the experiment, but I just want to say this was the first collaboration between Adan, me, and my PhD student Charu. Charu, where are you? Okay, she's on her way. She's not here yet, but that's how collaborations start.
Yeah, we started a few years ago, and we have had I wanted to say this week that we were going to be publishing it this week, but it's in the proofs.
Yeah, it's in the pipeline. It's been accepted for publication.
Sorry. Okay, so I really like the introduction because it was equivalent to skipping all those slides. So this is what I have been showing you in general, how the choice cards look. Sometimes you could do it as I have been showing you with figures. Sometimes you could do it like I am presenting to you right now. We did it in this way. And what is behind this design is what follows here. So before I go into the description, something that is important when you decide your discrete choice experiments is to use figures or illustrations mostly when what you are valuing is not kind of a common good, right? Like the ones I was showing you before, that it was less obvious for Mexicans in Mexico City before the pandemic what teleworking was or hybrid working, or the percentage of green in exchange of parking, blah, blah, blah. In this case, we went for something without the figures because we were interviewing potential car buyers who already had cars. So several of the attributes you will see are very obvious if you already are in the market of a car. So that requires less of the illustrations. If you ask me, I prefer to go for that distinction. Most of the current applications use illustrations. I strongly recommend you to think twice on whether it's going to help or not, because I have seen some applications that use illustrations that, from my point of view, kind of complicate more the decision than illustrated. So as much as I am encouraging you to do illustrations for your homeworks, if you come with a design and you say, well, I didn't do illustrations because I think it's a market that is more or less known, people can understand the attributes, that's a good reason to not include illustrations, okay? That is one important element in the design itself, the illustrations. Now, for all of you who this Friday are going to be delivering your homework, I basically recommend you to do three things. The first one, the equivalent of this table. A discrete choice experiment is going to be self-explanatory if you have a choice set table where you put attributes, the name of the attributes, the levels of the attributes, and the expected effect that you think it will have in the utility of the people. Whether you think that people are going to have this utility when the price increases, or whether you think that people are going to have a positive utility when the mileage or the efficiency of the car increases, and so on and so on. If you have that type of table, maybe in the middle put explanation so that you explain verbally your attribute. The people who reads it is going to have all the information needed in terms of understanding what is the discrete choice experiment about. The second thing that I recommend you to write is the scenario. What are you asking to place the respondents in? Like in the example of teleworking, I told respondents, please assume that your employer is offering you 2 days hybrid work a week. So whenever you think on your discrete choice experiment, think on that scenario, right? Because literally it's placing the person in a market. And then within that market, you are presenting them to buy this or that or that. And finally, for your homework, present your example of a choice set. With those 3 pieces of information, we should be able to communicate each other, right? And then you can receive feedback from Sangeeta and myself. It's a lot easier. Now, let's go to I wanted to use the second day to explain in detail our design because it has elements that are a little bit more sophisticated than the basic discrete choice experiment from yesterday, right? Yesterday, you had an attribute, you had the levels, you combine them, you did your choice sets, and you did your blocking, and you allocate them, right? Everyone is following me. Okay. In this case, we are going to do that, but we are going to do it with a little bit more of a tricky component. 2 tricky components. Let me start with the attributes. Price, right? We are going to present people to options to buy cars. Of course, the cars have to have a price. Now, one tricky component when you are going to present people to the price of a car, you could decide in advance the price of a car, right? You could say, well, I'm going to tell them that they could buy a car that is 1.5 million rupees, 3 million rupees, 5 million rupees. But you don't know whether that is too much or too little. For somebody, it could be incredibly expensive, and for someone else, it could be incredibly cheap. So we decided to go for this. That is an important decision you will have to take when you do your discrete choice experiment. Do you put the prices in levels, like I just said, in rupees or dollars or pesos? Or for a reason, you decide to present them as percentage changes? What we did was, we asked in the first section of the survey, you are in the market, how much are you expecting or planning? What is the price that you are expecting or planning to, what is the price that you are expecting to pay for a car in the future. Right? That's a beautiful idea, because then we know and we can refer to everyone's price in mind when we present them to changes in price that are percentage-wise. Because otherwise we will have made the big mistake of presenting to some people prices that will have been too low, or for some people prices that will have been too high. It will not have been a very informative discrete choice experiment. Okay, so that is one important thing that I want to discuss with you in this case. That is different from the two examples we discussed yesterday. In some cases, your prices might need to use reference prices that are individual. That could apply for cars, that could apply for houses, that could apply for a number of cases, okay? So for the next hours that you think on your own case, one important decision is whether you will want to present levels or percentage changes for prices. That was one important one. Then, mileage. Oh, no, let me skip this one for a moment. Engine displacement and transmission are two characteristics of the car that matter. The first one, in terms of power of the car, and that we know that is important for many people. They want a powerful car. And then transmission, many people prefer automatic. Many people prefer manual. That is definitely an important characteristic of the car itself. Now, one characteristic that I want to highlight that is tricky, but that was important. Social network. We describe it as the market share among family, friends, neighbors, or colleagues of yourself. So, will you buy this car if 20% of your friends, colleagues, all your network also has that car? Will you buy it if 60%? Those are the two values that they took. I want you to think on this because if evidence suggests a lot of the decisions that are taken in all the countries, but in particular in India, has a social norm component. So if you are thinking on applications in India, definitely go and do your literature review to see whether someone has documented a social norm or a peer effect component. That also matters in my country, of course. So you may want to discuss how that might come into your research. Among other things, because it has policy implications. This nudging, this pushing the peer effect, some economists don't agree, but some economists believe, like me, that is an important element of public policy. More importantly, in countries such as ours, I'm talking about Mexico and India, where sometimes it's difficult to impose monetary incentives via subsidies. For instance, in Switzerland, in Norway, in Sweden, of course, when you are talking about adoption of electric cars, of efficient vehicles, they come with their subsidies. But, subsidies for that in our countries are not a realistic option in general. There is no, in Mexico, subsidy to adopt efficient cars. However, our countries rely a lot on social norms. So, in that context, I will argue with a more conventional economist that it becomes a policy relevant information. Whether people will say, yeah, I will buy a car that 20% of my social network also buys. Okay? So we decided to include as part of the attributes social network. Now, before I go to mileage, because that one requires me to explain something else. Of all those attributes, I will say that there is not too much to discuss in terms of those are attributes that matter for buying a car. And social network, I am arguing it also matters. Do you see any problem of introducing it in the design as we have done? Can you see intuitively something that kind of is different from the other two examples? Yes?
Are we expecting that the respondents already know about these things like mileage, engine displacement? They are fully aware of all these factors? Or do we need to make them understand all these things? What are the options available in the market?
So those attributes when it comes to the attributes that describe the car itself, they already were taken from the literature review and from semi-instructor interviews and piloting. So they do matter in average for most of the people. Okay. So when you present them there, it's because you already have a good idea that it matters, that they will know what we are talking about. Okay. Of course, there is always, and that is something I should have said earlier, there is always a section in the questionnaire that explains each attribute. Okay. You are going to explain what they are about and their levels. That is something I haven't said. Okay. Yeah. Thank you. But something I wanted to highlight is this design is very unconventional in one aspect, which is, yes, you think you know.
I think the number of levels are different for each attribute. That was not the case in the previous design.
That's a good comment, actually. It doesn't have to be the same number of levels. That's okay. And in general, my recommendation is that the least levels, the better. Because that means that you are going to be having the lowest number of hypothetical combinations. And it's more manageable.
In the last case, there were the options there, no? Option A, option B, option C, and out of 3 options, there were 2.
We are going to have that in the next one.
Maybe, Adan, you can just first talk about that. First, we need to have attributes levels, and these are combined into choices.
Into the choices. And then those choices look like this. This is the equivalent of the choice sets that I presented yesterday. So something I wanted to highlight is the social network attribute does not describe a car. It describes the respondent context, right? So I want to take advantage of this example to tell you that sometimes you have to be very careful motivating some of your attributes, because some of your attributes may not strictly refer to the good that you want to sell, right? If you think about the 2 previous examples, when I present people to the teleworking option, I am selling them alternatives where you can spend 15 minutes going to the work, by bike or not, and paying this much. That is a good that I am selling you. In the other one, you decide between percentage of green in your facade, percentage of cars that you let go. Again, that is a good I am selling to you, for which you are paying. In this case, you are buying a car, but the elements describing that car actually includes a characteristic that does not describe the car itself, but kind of describes you. So that is going to be important, because in many respects, the strict interpretation of having that attribute is how much are you willing to pay for a car to be part of that network. That is what this means. People have or not willingness to pay to belong to a club driving that car. You see? And then it makes sense. I'm saying this because in a couple of presentations of this work, people ask me, so how are you selling a car with a percentage of people driving it? That is not a car. I said, are you forgetting the premium club, the exclusive club B? You know, it's exactly the same. It's like if you were asking people, how much will you be willing to pay to be part of a club? That is the network effect that we are testing here. And that's how it goes into the utility function, because you care about being or not in a club. And that's how we are aiming to get the willingness to pay for that. Okay. Now, yes, more questions. So think about this example, really keep it in mind, because the social network component is very interesting, because I believe that for many contexts, but in India and in Mexico, you guys should be thinking on a peer effect in many of the things that you are going to be modeling.
So regarding this peer effect attribute, how do we get on this number? Do we take it from the data that is available in the market, or do we do a pilot for that? Because for some things we can actually collect neighborhood averages, but a lot of times we don't have data on that.
Yeah, that will be the way. If you have some kind of number per neighborhood, you use it as base. But in this case, that there was these efficient cars that in itself they are still not available, we went for something that will increase the variation in the attribute. So 20% seem like a lower enough number, and 60% seem high enough. And then when it comes to analysis, it increases the variability in the variable. So but then again, we did piloting and we did testing, right? So when you do the piloting and the semi-structured interviews, you ask people if that number makes sense to them.
Okay, because sometimes we might end up giving them a wrong information. Like
Exactly.
60% of the people are using it and they might vouch to get it, but actually people are not using it. So
the phrasing matters a lot. There we said, imagine that you are going to decide between car A, car B, car C, where the car A has this price with this mileage, this engine, this transmission, and 20% of the people will be buying it. But we start from the beginning with, these are cars that are not yet in the market, right? So imagine that was the situation. Okay. Now, that part is very important in this in this country and in my country, and in other countries, but I wanted just to throw it out there because it's an alternative to consider peer effects. That's why I was talking with someone else, I think, yesterday or today. The other difference of our discrete choice experiment, of our design, in this case versus the two examples yesterday, is that this is called label design. By label, we mean what is on the top. Yesterday examples was choose between option A, B, C in both cases. Remember? Probably done because it was not a super salient component, but those are called on-label designs in the sense that you don't name the alternatives. So in the sense that they are as neutrally described as possible, right? Because if you, instead of calling an ABC, you say the good, the bad, and the, okay, we will be directing the decision, right? Who wants to choose the bad option, right? No one wants to choose the bad option. So that's another lesson, right? When you want people to choose without you having too much to push, make sure to not label your alternatives. Call them A, B, C, 1, 2, 3. Okay? But you may be interested in using the label or the name of the alternatives themselves as part of the design. And that was very important in our study with Sangeeta and Charu. Look at the labels. I mean, this is a little bit confusing, right? Because in the discrete choice experiment, we call them labels. But for the application here is also a label, right? The label is high star label car. We explained to the people that the government was considering introducing labels for the cars that were going to be telling you how efficient the car is. The label, the high label star that is going to go from 5 to going to take value 4 or 5, was going to be showing you the most efficient cars. The medium or moderate star label was going to be showing you the moderate efficient cars. And then we asked them to choose either the presently available alternative. Why did we do this? Because we wanted to know whether people will choose cars just for their label. In the other cases, the name of the alternatives themselves didn't matter. But in this case, we wanted to know whether people assign value to a label that says this car is efficient. Now, why did I leave mileage to the end? Because then, strictly speaking, they should not be caring for mileage. If the label is already telling you that you have a good mileage, why will you care about mileage? But we know that people assign value to labels, regardless whether they are accurate or not. So we decided to include both the label and the mileage. Now, we did something that is very innovative that I really recommend you to keep in mind. For those of you who already know impact evaluation, you might already know discontinuity design. Well, what we did was the following. When we presented people to the high star label, we vary mileage between 20 and 24 kilometers per liter. But then when we presented them to the moderate star car, we presented them to mileage that goes from 16 to 20. If the labels were accurate, or if the labels really only reflected mileage, they should not be high star and moderate star with 20, right? Strictly speaking, the moderate should always have lower kilometers per liter. Are you following me? Raise your hand if you are not following me. Okay? So we are creating a discontinuity here. The same level of mileage with different labels. That is the discontinuity regression design for impact evaluation. You have the same mileage, and the only difference is you have a label that says I am best energy efficient. You have a label that says I am moderate label efficient. Having the same mileage, are people willing to pay for the one with a better label? That's the hypothesis there. So just to recap, this example we are discussing today is different than yesterday's in at least 3 aspects. One, the price is presented as increases in a reference price, a percentage increase. 2, we have labels. We are labeling the alternatives. They are not A, B, C anymore. We are strictly labeling, but this is so important, because if you, for whatever reason, mistakenly label your design and it's not part of the design, you are not going to be able to get the value for the labels, or you are not going to be able to identify the values for the other attributes. And finally, we introduced a discontinuity in the mileage, a very artificial discontinuity. That is going to allow us to estimate value for the mileage at the same time that value for the label. Okay? Think about it, because that should be collinear. The best mileage should be associated with the best label. But we broke that collinearity artificially with our design. That is something that you have to be very aware always. How do I break with the collinearity in my design? Okay, one more element. That I want to highlight why we believe that ours is a very I don't have it here. I should have it here. Yeah. The other element of our study that was important is what Sangeeta already introduced. Through a split sample approach, half of the people in our sample answered this discrete choice experiment, these choice sets, with no information extra. And the other half of the people, we told them before presenting them to the discrete choice experiment, the government of Delhi is considering to start a permanent, you call it uneven program. In Mexico, we call it Hoy No Circula, because this program will be very similar to the one that in Mexico we have been having for a while, which basically consisted in what was already described. You don't drive your car if you have uneven plates in a given day or even plates in a given day. Why do you think we wanted to use this split sample approach? What are we aiming for by informing half of the people that the government is considering this type of regulation? What should we expect? Anyone? So we are exploring preferences for energy efficient cars. And now we are saying to half of the people, and the government is considering to implement this type of policy where you will not be allowed to drive in an uneven or uneven unless you have the car with the best label. We wanted to know whether people were going to be interested in the efficient cars under a regulation that actually will help them. Actually, if the car that has the base label help them to get rid of the regulation. Why are we doing this? Because evidence shows that even when the efficient cars are available, and even when the labels could have some informative value, it's not enough. We already had done literature review, and we knew that even when the interest could have been good, and the question of the paper was, what will happen if on top of this labeling system we have a regulation? Will the regulation make people want to drive cars that are more efficient? So basically, to me, when I explain this is, are we scaring enough? Are we scaring people to drive the car or not, to drive the efficient car or not? Now, as Sangeeta mentioned, if you think about it, the willingness to pay, the extra willingness to pay. So when we do the split sample, when we ask people, how much will you be willing to pay for this car? They already reveal a willingness to pay for the label. Now I tell you, how much are you willing to pay for the same car under the regulation that if you don't have the best efficient car, you don't drive it every day? The difference in the willingness to pay is your willingness to get rid of the regulation. Is an estimate of regulation cost. And that is ultimately one of the most important contributions of our paper. There are two previous papers that did something like that with contingent valuation, but we are the first one doing it with a cool discrete choice experiment. And the important thing is the following. There is very little literature on regulation costs on households of policies such as this. So if by any chance any one of you in your literature, in your studies are coming across regulatory cost, what is the cost that people have to face because government implemented this policy? This is a very nice way to estimate them. And the idea is very simple. You create an alternative and you sell it as the alternative for people to get rid of to get out of the regulation. How much will you pay to get out of a regulation? Is a good estimate of the regulatory costs that people are facing. And that's what we are doing here with that split sample. We know how much people will be willing to pay under the regulation for the same label that they already, in the other sample, they already said, we're willing to pay 100, and then in the other one, they are saying, well, we're willing to pay 200. The difference is how much are they willing to pay to get out of the regulation. What do you think? Does all this make sense? Okay. Very good. What time is it? Do we have more time? Yeah. Okay, so why not I give you some chances for questions to transition to the other, because today I'm going to explain mostly the design. I'm going to go to another topic, but on Friday and part of tomorrow we are going to discuss the results, so that I explain to you. And I'm going to give you a little bit of time to go and read now that you guys hear me explaining it. I'm sure that you are dying to read the paper that we have in the Google Drive. So take a look at the paper, and then we will discuss tomorrow the results, and we'll try to make sense out of them. But why not you have some questions?
Completely. Today's idea is to give you designs of different papers, and what do we find, results, how do we report results, that'll be
Tomorrow.
The next.
No, sorry, Thursday.
Thursday, yeah. So that's good. Tomorrow they can also read.
Oh yeah, that's actually work. Yeah. Okay, so I know that you already have access to the Google Drive with the references and with the, so take a look at those papers, okay?
So, Pranav, do we also have papers on the Google Drive? Have you uploaded papers?
Yes, ma'am.
Not just the title of the paper, the actual paper is there?
No, ma'am.
No?
So we need to do that.
Okay, we will upload also the
Upload the papers so that
the paper. Okay. Questions about design? No? Clear? Yes.
Yeah, I'm sure that.
So I was a bit curious to know that can we also switch between the label and the actual information that is not related to that label to see if the label matters the more? Like if people are skipping through all the other information when they see that label. For example, in case of packaged food items, we usually see a label, and if it is high in fiber, people don't look at the back and see all the nutritious content. So whether they are actually considering all the information or they are just getting impressed by the label and choosing that option.
Exactly. That was part of what we wanted to test. So something that that's a very good question. I don't have here examples because I myself have not done it, and usually I prefer to present examples where I have some experience so that I can. But some of our colleagues in ETH, Julia and Massimo. So with respect to labels, and this is a very important topic in discrete choice experiments, and I think that for your case, when you are dealing with how to inform or how to nudge people into taking decisions, right? Like for instance, in India and in Mexico, we have people facing problems of obesity. So a lot of the times, one of the alternatives is to present people to the right information. So there have been some studies with labeling where they basically explore whether people are paying attention to the label with discrete choice experiments. So what they do is they design the label differently. For instance, for appliances, you could inform about energy efficiency, or they have tested informing about energy savings. In a given year, you will be saving this much energy. And even further, they are monetizing the savings, right? The label presents you, there are three different labels. One presents you to savings in kilowatts and others present you to savings in monetary value. And the typical one up to today is the one that presents you to savings in to a label that tells you how efficient in terms of use of kilowatts is with respect to others. And then after that, they test whether people were paying attention to specific characteristics, one, and two, for which one of them they are revealing more willingness to pay. So that is definitely an important question in terms of design and in terms of information. So if any of you get interested in that type of literature, you should definitely think that discrete choice experiment actually help you to inform the design itself of the label. Right? I want to take advantage of your question to highlight how cool is to do a series of discrete choice experiments where you basically end up concluding and tell the regulator, you know, now that you have decided to put a label, don't do the typical label where you say A, B, C, where blah, 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 but instead do something where what you communicate is energy savings in money. That is what gets people really interested and really best informed. For instance, the one about obesity and the one about nutrition facts. I don't know. I mean, you know, I never look at it, right? Do you have probably some studies on that, right, Sangeeta? You wanna mention something about that?
Yeah, I'll just add on to that.
Because there is evidence that who looks at it?
No, Bhavna, that was a very good question because I also work on nutrition. And there's a whole literature and so many discrete choice experiments on these nutritional labels. And the last one, which I just reviewed for my journal, so, you know, how information matters. And they're saying that so much of food gets wasted because if you look at the label, it says best before, February 10th. And I'm not going to use that food after February 10th. So now there's studies, they say, what does it mean? Because if you change that information to say that after February 10th, it may not be as good, but it's still edible. You can consume it until February 20th. Then people will just consume it after February 20th and food waste goes down. Similarly, you know, like there's so much research going on, low sugar food and, like fresh BC or tomato ketchup, fresh tomato ketchup, right? Tomatoes have to be fresh, but they're not fresh anymore when they're in that water bottle. So yeah, in food and nutrition, this labeling and discrete choice is a very large literature.
So that's definitely one line of research for all of you. In most of the literature, health economics, energy economics, environmental economics, agricultural economics for organic labels, etc., etc. Oh yeah, cool.
Good afternoon, sir. Nirmal sir.
Yeah. So
you can ask
he can
questions
say, Nirmal can. Hello, Professor Nirmal, please say your question. Yeah, he's faculty at the University.
Oh yeah, cool.
So ideally, people use conditional logic models, and the interpretation is usually in terms of utility. And some also kind of use mixed logic or multinomial logic models. So if we are thinking of, for example, multinomial logic model, so I can see your alternatives like high star level card and moderate star level card. So I'm not sure whether it passes this IIA assumption, what is called the independent and irrelevant alternative. So I wanted to relate with the classical Ulrich's example of, the different modes of transportation. For example, you used to commute from your house to the office, right? So you have bus, for example, you have car, and might be you are using other modes of transportation. So they are kind of, in one way or the other, mutually exclusive. But if you look into, for example, bus only, like the different colors of the bus, and if you take them as choices or alternatives, then your IIA alternative might fail. It may not pass. So I was thinking on that line whether, how serious is this issue in this case, whether you have looked into this IIA assumption or not when you talk about this alternative. And my second question is about the price. So if, for example, if you want to estimate the willingness to pay for other attributes like, one additional mileage or for engine displacement, for example, then ideally, I think that you need to specify price in terms of price itself, right? In terms of, for example, Indian rupees or in our case, Nepalese rupees, something like that. But if you place a price as like, as you have placed in your experiment, like 50% of the reference price or 10% of the reference price, how do you actually, calculate the willingness to pay? So ideally what I understand is that when you calculate the willingness to pay, you usually, divide the coefficient of the particular attribute you want to estimate the willingness to pay by the coefficient of the price, right? And that gives you the willingness to pay for that attribute. So how do you respond to that? Thank you very much.
Thank you for the questions. They are very useful. I think that now it's time to start addressing those concerns. Let's start with whether this is, what kind of models do we estimate with this data? There are two general models that we use. Conditional logic and mixed logics, as the professor mentioned. The conditional logic is estimated under the assumption that these are homogeneous preferences. Remember yesterday I mentioned how if I ask you to answer my design, and because I kind of divided it by blocks and by choice sets, I am assuming that everyone is going to choose as if all of you were the same people. And there is another assumption in the conditional logic, which is when you choose one of the alternatives, it does not matter or is independent of the other alternatives. The example that they like to put in transportation, as was mentioned by, which is a very important topic, a very important area of application, the IIA, which is independence of irrelevant alternatives assumption, implies that if I am presenting you for instance, two options, and one of those options is the bus red, and then there is the same alternative but the bus is white, it should not matter. The color should not matter. It should not matter whether the other car is red or the other bus is white. So there is this assumption that there is only the relevant component in the description of the attribute, and that what is not presented is irrelevant independently of the alternatives. So the IIA does not hold. We came up with the mixed logic method. The mixed logic allows for heterogeneity preferences or to relax the IIA assumption. Sometimes, as well pointed out, the decision between choosing the moderate or the high efficient cars kind of relate to each other. You are not necessarily choosing them independently of what the other has. I want to go into detail later today, but mostly tomorrow, on what exactly the mixed logic does in terms of econometrics versus the conditional logic. But those two distinctions are important. The conditional logic works only if the preferences are homogeneous, and the IIA holds. By now, you may guess those two almost never hold. So what we are going to be learning is the mixed logic model. tomorrow, which allows for heterogeneity in preferences and to get away from the IIA. The other important thing is there is one version of the mixed logit that is called latent class logit or latent class model. In general terms, what the mixed logit does is that it says that we have such a level of heterogeneity in preferences that each of us can be modeled as if we have preferences that are randomly distributed. Literally, as if we can take them from a distribution, and I can take your preference from another distribution, and so on and so on and so on. And it models those preferences as if they were continuously distributed as a normal. The latent class model is a version of the mixed logit that says, no, preferences vary, but they don't vary that crazy, that wildly, that everyone can be modeled with their own normal distribution. It varies by segments. So I am able to identify a segment of people that likes one of the attributes a lot, a segment of people that they are kind of indifferent to that attribute, and a segment of people that dislike the attribute. That is called latent class analysis, finding mixture models. The reason why it's kind of popular in our literature is because it helps identifying the classical marketing tool, the classical marketing message, right? Segments of the market. We are going to be able to divide the market between those that like, those that are indifferent, and those that are disliking the attribute. And that is very powerful. Charu on Friday is going to be talking about our own latent class analysis to that exercise that I presented to you a few minutes ago. And you will see that we were able to characterize those groups between people who really were happy about adopting efficient cars, people who were not that happy, and people who actually kind of was out of the radar. Okay. We are going to be talking about those. There was another question about models. What was the second question? Oh yeah. So how do we use these changes in prices that are expressing preferences? That is a great question because I forgot to mention that before. I should have mentioned it. Even when you present changes in percentage, it is true. In general, we want to estimate the changes as in levels. So what we did was, sorry, give me a second. It seems I am not too good at doing two things at a time. Yeah, once you present it like this, what we did was we multiplied times the price that is the reference that the respondent said that it was having in his or her mind. So we put everything in rupees, so that when we do the analysis, we can do it in terms of rupees. How many rupees you are willing to pay for this car or this label. So that goes into labels once you have that answer. That's why we get the reference price, right? You have reference price plus reference price times 0.40% or 10%. That is one important clarification. However, remember the example that I presented yesterday, the one on the green areas. There, everything was percentage changes. So depending on your exercise, you may or may not want to do it in levels. But generally speaking, for willingness to pay in rupees, in US dollars, you want to do it in levels. You want to multiply this and times the price and make it in levels. Okay. More questions online?
Yeah, hi. So, Sirin ma'am, you can ask a question now. Hello, ma'am. Sir, so they here on chat.
Am I audible? Am I audible? Yes, yes. Am I audible?
Yes, ma'am. Yes, ma'am. Yeah. Yes, ma'am. You may ask.
Am I audible?
Yes, yes, ma'am. You may ask.
Am I audible? Yes, yes. Am I audible? So my question was my question was that we are as we are discussing about willingness to pay about. So there is a possibility that when we are performing this survey and we have taken a sample of people, so there is possibility that we may get different observation, different results from the same sample if we are performing at different times.
Questions here in the audience here?
Are we supposed to have levels exhaustive and mutually exclusive to each other?
Can you repeat that?
Are we supposed to have levels exhaustive and mutually exclusive to each other? Is it necessary?
Yes, in general they have to be exclusive, right? They have to not contain the other ones, because otherwise it's difficult to make the decisions. But they don't have to be exhaustive. Not necessarily. The range of the values that you cover come from the semi-structured interviews and the piloting. In particular, the prices, for instance, it's very important that you decide slowly but surely what is the range of prices that you are going to pick. But in many other of the attributes, you have to also test whether the range of values is the relevant one for the decisions. Sometimes the real market doesn't have that range of values. I told you yesterday, for instance, in a subsidized market, the price doesn't reach the highest value that they could potentially reach in a real market. So that is a value that you want to consider in your discrete choice experiment, but you need to be testing how high. And I am about to start discussing right now that specific question. Let me see if we can have that question, and if not, the next part of the conversation today is price, because that, as economists, is one of the most important ones that you have to be choosing. The other ones are also very important, but price.
You can take the question from chat directly. So this one question.
It says, it is quite similar as impact evaluation, like in the presence and absence of government regulation towards the preference of each level. How are different here with discrete choice experiment? This is a very good question. Thank you. Think about it, and later on I am going to be talking about another example that is more clearly related.
Can you please repeat the question?
Oh yeah, sorry. The question is, it seems that it's very similar to impact evaluation in terms of how does the...
Actually, I also had that, so it's like RCT.
It's an RCT?
Right?
It is. The only difference is we don't have the pre and the post. And therefore, this is not revealed. It is stated, remember. But when you don't have, one, the policy really implemented, and two, you don't have the collaboration with the government to actually do a field experiment, and three, you don't have the funding to do the field experiment, this is a very good alternative to do to gain insights of what an impact evaluation will look like? That will be my answer. It is not an impact evaluation. It is an RCT in a stated preference dimension is called. The experiment, the impact evaluation gives you the effect in the revealed preference world, the real effect or the observed effect. We, with this kind of design, give you a stated preference effect. Whether it's going to be observed in the real market, that is always going to be a big if and but. I'm going to be discussing that also as well in terms of external validity of the results. Give me a few more hours. But before that, I want, because I knew you guys were going to start getting tired, I wanted to start with what to me is one of the most practical components of the design. Okay? This that I'm going to tell you refers to the price, and I usually refer it to the price because it's one of the most important components in economics. But you will see that if you take it to the heart, you should be implementing it for every other attribute in your discrete choice experiment. Okay? So I am going to be using the example of do we have a marker? If not, it's okay.
He usually gives both.
I forgot to mention it, but if not, you don't worry. I have oh yeah, perfect. Excellent. Maybe those in the, now that I think about it, those in online will not be able to see very well. So what I'm going to do is I'm going to put in the screen one figure that I think they could follow the idea. Give me a second. This. How do you design the range of prices that matter in your discrete choice experiment, in your stated preferences dimension? Think about it. Think about the case of water, subsidized water, like in Mexico, or subsidized energy. If you go right now and ask me how much is the kilowatt of electricity in Mexico, I don't really know, but let me say 5 cents of peso. And then I analyze the tariff structure of the electricity market in my country, and the minimum that people pay goes from 0.1 to 0.8, for instance. They are paying this for electricity, for every kilowatt. Many times the mistake that people do is, well, they say, let's use the market price as a reference. And then they move a little bit away from the market price. Do you want to move just a little bit or a lot from the regular market price? Or imagine that you don't have a market price, because we are talking about a truly non-market good. How do you set the prices? The thing becomes half economic theory, half empirics. Actually, I should tell you, half economic theory, half statistics. I'm going to explain the example with a contingent valuation design. What you want to do is you want to go and test your initial values, let's say on 10 people, each of the values. you are economists, and you should know that the ideal figure that you should obtain, if this here is percentage of yes to each of these bits, should look like this, right? Because it's a demand curve. The more you pay, the less people should be saying, yes, I want to pay that, right? Now, my question to you is, which values should be this, ideally? Remember, for those that are online, we are talking about the percentage of yes over the y-axis and the bits that we are presenting, or the price ranges that we are presented in the discrete choice experiment or in the contingent evaluation. And we as economists have established that the curve should have a negative slope because it reflects a demand curve, right? The more you are asked to pay, the less willing you should be willing to pay. Everyone follows me there and here? Well, in terms of design, this number should look like this. The range of prices you want to cover is the highest when you go on pilot. 20% of the people should tell you yes. To the lowest, 80% of the people should tell you yes. That is the range of prices. But that range of price, we cannot know it if we don't do piloting. That's the only way to know this. You are going to be establishing values that are relevant in your market, but you need to go and do piloting. In my example, this is the range of price that is covered in the market from 0.1 to 0.8. But the one, I only came out with it through piloting because I realized that people will be willing to pay still 1. 20% of the people who were presented to 1 said yes to 1. And 80% of the people said yes to 0.1. Why am I coming out with these percentages? Anyone has an intuition? That is, the reason is very statistical.
80 by 20 Pareto rule.
Can you repeat that?
It is because of that 80 by 20 Pareto rule that we say that you have 20% on the higher side and 80% on the lower side.
But why?
Pareto rule says that we choose.
Oh, that's true. The Pareto rule also says that. That's true. I didn't remember that. But you know, statistically, is very related to the logit model. When you run a logit model, and who here has run a binary logit model? No one? Okay. When you run an OLS, ordinary least squares, sometimes what happens is that if the dependent variable doesn't have enough variation, you can explain nothing, right? I mean, if it goes from very little to just a little bit more, there is nothing to explain in the dependent variable. There is no change in the behavior that you want to explain. The same happens in a logit model that explains the probability of saying yes or a variable taking 1 versus a variable taking 0. If a lot of the times it takes value 1, there is nothing to explain. Everyone chooses 1. And if a lot of the times it takes value 0, there is nothing to explain. Everyone chooses 0 or chooses not to. So basically, the very logic is statistics. If you want to explain variation, you need a range of prices for which people report variation, something between 80% to 20%. In this application I'm showing to you, the people that we were asking if they were willing to pay an extra for entering in Galapagos Islands, they went, let's focus on the one in the middle. They went from 73 saying yes to around $100 to 42% saying yes to $700. I always show this because if I follow my own rule, I should have extended that value to at least 800 because I still have 42 people saying yes to 700. My colleagues didn't let me do that because they said that I was too crazy. It was going to, what happens? The more you present these numbers, higher and higher range, by design, I'm going to be obtaining a higher willingness to pay because I'm going to be obtaining that more people say yes to 800. So that is the balance that you have to consider. I personally would have loved to take it to 700, to 800, 900. Because I believe that the people visiting the Galapagos Islands very likely can pay 900 to enter. But they didn't want me to take it that long. We were anyway already taking values relatively high. But it depends on your judge and your call. But ideally, I recommend you that the range of prices that you consider, if you test them, 80% of the people say yes to the lowest bid, and 20% of the people say yes to the highest bid. That will be the range of prices that is relevant in your market. Does that make sense to you? And there is economic theory behind this. Why? You want a monotonically decreasing negative slope curve. Otherwise, this is a bad curve of demand. And you also want it, statistically speaking, covering as much range as you can explain, as much variation as you can explain. Okay, that is in terms of the range of prices. Okay, then how many bids should you consider? Again, if you go and test your bids, my recommendation is you test them so that you get the monotonically decreasing values. In this case, the reason why I present this is because I am very happy of how it worked. Sorry. I may have run out of battery. Yeah, I didn't connect it. Oh, it's coming, it's coming. Yeah. There. I am very happy with this example because, look, look at the line in the middle. We were able to present bids that the percentage of people saying yes goes monotonically, decrease monotonically. The people answering yes to 150 are 72. The people answering yes to 150 are 61. And then we got to 52, 42. We tested these values, and in some cases they were coming less monotonically decreasing. And for that, I like to present a case where we were less successful, so that we all learn from our mistakes, right? Let's not pay attention to the colleagues because otherwise they're going to get mad at me. To the collaborators. No, but I mean, this is what happens. This is something that you only learn by doing. This, just also pay attention again to the one in the middle. So I like to go to these presentations and present. The previous one is one that I am very proud of, because we did 10 semi-structured interviews, 3 pilotings before going into the final design. We did it very well. We had the time and the money. And I had a group of collaborators who didn't let me stretch too much the values, right? We had very passionate. This one, we didn't have the resources, we didn't have the time.
Was that Massimo?
This one is Massimo, yeah. So, this is a terrible demand curve. It has a negative slope, more or less, but it's not monotonic. Do you see how by the end, between these 3 last values, they are the same value, 21, 21, 19. Something I want to highlight is how we wasted information. We have 1, 2, 3, 4, 5 bits. 1, 2, 3, 4, 5, 6 bits. And the last 3 bits are gathering me practically the same information. 21% or 20% of the people to the 3 last bits say yes. So what should I have done? I should have had only the last one. I don't need the ones, the 2 previous ones. So I should have kept it in that last one. Then I should have gone to this one, the one that has an answer of 26%. Then I should have gone to the one that gives me an answer of 38%. And even more importantly, I should have gone down probably to 0.1 in this case, which is what was going to be like 100 Swiss francs. Why? Because I am not obtaining yeses for the lowest values. My demand curve only starts in 40. So I only observe half of the demand curve. So I could have had 5 bits instead of 6 or 4, and I needed one at the very top, at the very left, to actually capture a good monotonically decreasing demand curve. Here we are not considering the relevant range of prices. We are missing the ones in the left. Do you see? I hope that you can see how the mistake I would like you to avoid. Yes?
No, I don't think this is very clear. So first of all, there are 3 curves, right?
There are 3
demand curves.
Yeah, sorry, here you should just focus on the one in the middle. Okay. In the middle, yeah. The other ones are, yeah, just in the one in the middle. Ideally, we would have wanted to have 80% at least of yes in the very left.
But we don't get, we just get 40%. That's what you try.
Yeah, exactly. Because the lowest bid that we presented was 50 CHFs. If we had presented 5 or 10, we will have obtained a yes that was higher than this. The lowest was okay. A little bit redundant. This is redundant information. We are not taking the best advantage. This is not an efficient design. And here we are missing one to get more yes.
Okay, yeah.
And by not obtaining or by not putting the right or the relevant range of prices for the respondents, we are losing information. When you, like I wanted to do in the previous design, increase the bid, by design you are going to obtain, in average, a higher willingness to pay. By not including the lowest bid, again, you are calculating a higher willingness to pay. Because we don't know how many people wanted to pay less. So it's very important that you consider these things in your design of prices, but it applies to your all other attributes. Whatever attributes you are thinking, more or less you want them to vary across this. Here I am presenting you only in one dimension, right? Ideally you want to do it in one dimension for all of them and later on to all together. Questions? This is one of the most important elements of design of discrete choice experiments and continuous evaluation. And I didn't learn it in my class. I learned it only by doing in the last years. Yes.
So here's one online question from your slides, and that is from Lynn. He's asking that is the car choice experiment between two choice set. Why are we keeping the market share among families same, which is 60%? The question is that.
Oh, in the previous example, the choices that I am presenting is an example. So what happens is every person was presented, and there, thankfully, Charu is here because she's going to be the one remembering. But every person is presented to a different choice sets. So this is only one example of the choice sets that the person sees. There were 5 or 4 of these? 7. 7 of these, each person responding. And in some of those cases, this 60 varies. In some of those cases, the person saw 20, and in some of the cases, the person saw 60, so that they could compare. In this specific example, they are presented to the same 60%. Right? So what varies here is the price, the engine displacement varies, and the transmission, but not the network. And what happens is that you want to vary this in the different choice sets that people see, so that by making them do different decisions, you can infer what made them take which decision. So in some cases, it's okay to have the same values in some of the attributes, so that you keep those fixed and you move the other ones. Okay, very good. Okay, more questions. I am very interested in knowing if you got the design of the price, because that's more or less what I will say is one of those things that you are not going to see in the books.
I mean, I should add that even I have not seen in any book how to design price. We just think that, okay, we take some price, reference price, and take 20% more and 20% less. But I think this was an insight that, statistically, how to make sense of what should be the range of prices that you're going to offer in your discrete.
I haven't written.
Quite an insight.
I haven't written the paper, but I should write the paper in economics letters, because I have not seen it in the design.
Textbooks explain this.
No. I came to the realization just 3 years ago.
From your own work.
From my own work.
So that, I think that's the advantage of having someone who has done these experiments.
Yeah. And if you talk to people who are more senior than me, I have in a tricky way asked the question to know whether they know what I now know, and I have realized that they don't know. So I think I have a particular opportunity to write an economics letter short paper explaining, because the essence is that is.
You should actually write economic letters, giving the logic of 2080 and relating it to logic.
Yeah, it's that simple. Yeah, and then to show this example, and then to show the other example, the good and the bad. Massimo will be happy. But for real, and thanks Sangeeta for pointing out, this is a very, very from expertise, from experience. No textbook is explaining this so far. Let's see if we write the textbook. But very importantly, if you apply this same logic to the other attributes, you are going to get a nice range of values for all of them. If you realize, oh yeah, this percentages also hold for the other ones. That includes that when you do your summary structure interviews, you ask people attribute by attribute. And then later on, you do your piloting with your bundles of attributes. Okay? Okay. I'm going to give you the break because I also need my break. Yeah. But thank you so much, and let's return in 30 minutes. Is it like this? Thank you. We are not going to learn it in the book. It's out of experience, and it is also very important for the rest of the design. So the general question is, what range of values should my variable or attribute take? Right? I thought about prices here. So for the time being, let's talk about price of, like in this example, is how much will you be willing to pay to enter in the Galapagos Island Natural Park? The other range, the other kind of idea that you could be thinking is, what is the range of, if you are asking people how many hours a month will you be willing to put in order to have better urban green spaces in your city? That is one that we are doing there in Umea, where I live. That is another kind of payment. The other one that I can think on is, how many hours will you be willing to commute to take a sick person to the doctor a month? I'm trying to come up with other examples. And in general, let's talk about, for the time being, about continuous variables, right? But it also applies to categorical variables, and we are going to make a little bit of an example there. If that is the general question, let's go to the one of prices. You could say, what price should I put as the reference in my discrete choice experiment? Oh, I am thinking on one example now. We did one study where what we were interested was, are people willing to support a reforestation project in a urban place, in a urban city, that is in a semi-desertic part of Mexico? And we told them, look, if we reforestate in these spots, we all are going to have better air quality. So the question was, how much will you be willing to pay for this reforestation? Afforestation, actually, that's the right term, afforestation. I learned that with my colleagues in natural sciences. So one of them said, well, we should be asking around the price, around the cost of afforestation, right? If we know how many hectares need to be afforested in the city, and we know how many head of families, head of households are, and we assume everyone pays the same, we should have the total divided by that, and then that is what we should be asking, around that value. And I said, that is an excellent suggestion. So let's imagine for the time being that when we calculate that value, that is very much the logic behind proposing that value is that if we were going to finance the project of afforestation, and everyone or most of the people are willing to pay around what they will contribute, then we could say, okay, let's finance it, right? Let's assume for the time being that that value is, I don't know, 500. Actually, I am glad that you are asking me this question because I want to take advantage to make some conceptual distinctions. One of those is the following. Imagine that everyone says to that value, yes, I will be willing to pay that value for afforestation. Based on the logic of how we set that value, the conclusion will be, then the government could implement the afforestation policy because everyone is willing to pay the corresponding amount if we were going to allocate it evenly. Do you follow me? Am I being? That is one answer, and that is an important one, and that has a very important public policy implication. Okay? Implicitly, what I am telling you is, if everyone says yes to that value, the afforestation program passes the cost-benefit analysis, right? It costs 100,000, and based on the benefits that I am estimating, everyone seems to benefit at least as much as it costs. Everyone is willing to pay the corresponding to cover the 100,000. So let's build it. Let's do the afforestation program. Now, tell me something, one of you or all of you. Can I say what is the value that people assign to the program? Can I say how important is for the people this program? The answer is no. For those of you who are still thinking about it, let me give you the other example. Imagine that with the same value, I am assuming a 500. In the previous example, everyone say yes. And then I say, go ahead, government. Everyone said yes. Now imagine in another example with the same value that everyone says no. Then of course I go ahead and I say, don't do it, government. No one wants to pay. Does it mean, in the second example, that people assign value 0 to the afforestation program? No. Okay, who is going to explain me what is going on here? Thank you.
I think it's like a question we asked in contingency evaluation. So we generally ask him, the first question is that, are you willing to pay this benchmark? We set the benchmark and ask the question, are you willing to pay or not? So if the person is saying, okay, I am willing to pay this certain amount, then the next question is, are you willing to pay 100 rupees more or 100 rupees less? So that we are trying to find out that what his consumer point of view, what is his willing to pay at that point. It's like it may change from person to person. So directly going on to like everybody should give 500 rupees will not lead me to any valuation or my contribution towards that project. So if somebody is saying no to 500, it doesn't mean that he don't want to pay. It means that he may pay 200 rupees, not 0. So we have to go to that. We have to ask the next question: are you willing to pay 100 rupees less to this or 200 rupees less to this? If he says yes to that, it means he's willing to pay 300 rupees. So there's a difference in that context.
I like the part of your explanation. If anyone wants to contribute, raise your hand. Someone else? I want to complement, and in the meanwhile, let's keep the microphone there in case that someone else wants to contribute. But what you said, I want to rephrase it in the following way. When we ask people, are you willing to pay 500? And they say no. What they are saying is, what they are revealing is that their willingness to pay, the only thing that you can conclude is that their willingness to pay is lower than 500, right? You cannot conclude that their willingness to pay is 0. You cannot conclude that their willingness to pay, that they don't have a willingness to pay. And if they say yes to the question, are you willing to pay 500? And they say yes, you can conclude that their willingness to pay is 500 or more. So, if in my example at the very beginning, we only were asking, as my colleague who was a biologist told us, well, the only number that matters, she said, is this number, the 500, because if everyone is willing to pay 500, we can say that the program is beneficial for everyone and we can cover it with the willingness to pay. And I said, yeah, sure, I mean, that we can say, that she was right. But we cannot say what is the value that people assign, because even in the case that everyone says yes to 500, there might be many people who value the afforestation program even more than what it cost. That's what I want you, I want to take advantage of you not understanding me before. Sorry, no, actually that was the wrong phrasing, sorry. Me not explaining it correctly before, or not explaining it clearly before, to try to actually get into the concept of what is value, what is cost-benefit analysis, and whether the value of someone should or should not be included in the cost-benefit analysis, and whether the value that we get from discrete choice experiments and contingent valuation imply that you should be recommending to create a market or not. Okay? Okay. So let's go to the beginning. That 500, even when it could make sense that because the cost of producing something is 500 per person, is not the right range of values that you should be covering. And it's not only around that number, because again, my colleague who was a biologist and she didn't have to know, she said, well, I mean, 500, 550, and 550, she suggested, right? Minus 50 plus 50. She says, that is the important, relevant range of value if people want to pay around what it costs to do the afforestation program. And it's so funny because a biologist talks a lot about values of ecosystem services. And I told her, what you are saying implies that you think that the value of the ecosystem service is equal to the cost of providing the afforestation program. But there are multiple reasons why people might value something more than what it costs. It costs 500, but it might be that someone is willing to pay 800. And it might be that even when it costs 500, someone might not be willing to pay more than 200. So that is the logic in general that you should be thinking whenever it comes to the range of prices that you should be considering. It's not only about how much it costs to provide a service or the good that you are suggesting. If you are suggesting a new cropping technology or a new way to use water in a very efficient way, and you might know how much it costs, but you have to stretch the range of value that you ask in your survey. You have to increase the bit and you have to decrease the bit. Now the general question is, how much do I increase it? Should I increase it to a number up so high that no one say yes? The answer is no. Should I decrease it to a point where everyone say yes? The answer is no. The reason of why the answer is no is, for those of you who have taken your statistics and econometric courses, you are wasting information, or you are having redundant information. When everyone says to a value no or yes, there is nothing to explain. Everyone is deterministic. If you run a regression with those, there is no variation that you can explain. Everything is explained by the bit itself. Everything that explains that you say no to $1 million is that it is $1 million. I have no $1 million. So in order to have a variation to explain in a regression that explains that someone say yes or not, you need that it is not everyone saying yes and it is not everyone saying no. That's why the 80-20 rule. The 80-20 rule statistically is when you run enough binary logics, you realize that having more yes than 80% doesn't give you good standard errors in the coefficient. Having less than 20% doesn't give you good standard errors in the coefficients. That's why you should stretch it up to 20% and 80%. And I said that I also wanted to take advantage to relate this question to what is the recommendation in the end coming from these studies. Something that I want you to take in mind, and I will give you the word in a few minutes, is the following. A discrete choice experiment is a way to simulate a market and a contingent valuation as well, and right now we are talking about both. So if we are simulating a market, you truly want to convince people that the government or the entrepreneur or whomever in your scenario is involved is going to implement the policy or the change if it passes the cost-benefit analysis. If as many people as possible can pay for it, and it can cover the cost, so that actually is a good investment from the private perspective, from the government perspective, from the welfare perspective. That's why you want to definitely consider somewhere in your range of prices the cost of providing the service, for sure. It has to be covered. But you have to consider that people also may value even more or less than the cost. So sometimes the cost is going to be very much in the right, potentially outside the range of people saying yes, right? It could be that the cost is 800, and when you did your study, you made it up to 700, and only in 700 people were saying, 20% of the people were saying yes. That is what it is. That is the range of prices that matters for people in that respect. So do consider the cost, and try to incorporate the cost in the range of prices. But what is the range of prices in there? Is the range of prices that matters for people, because people are the one assigning value to the service that you are providing. Remember, in many respects, we motivated the course because we want to inform public policy for climate change. And unfortunately, a lot of the times you are going to find that a lot of the policies to tackle climate change are not valued by the general audience or by the specific population, so that it passes a cost-benefit analysis. And that is going to be the conclusion. Whether that is good, whether that is bad, well, you will have a public policy implication section. Okay? Now, as much as you are going to be simulating a market, and as much as the goal of a good discrete choice experiment is to convince people that this is going to be implemented if it passes the cost-benefit analysis. Remember, what you want to obtain is an estimate of how much people value the service. That's the ultimate goal. Not always you are going to end up recommending the creation of the corresponding market. And actually, not always is really the ultimate goal. It is an artifact. the simulation of the market is an artifact so that people get convinced that they will have to pay, so that people state their values. Once they state their values, you say it passes or doesn't pass the cost-benefit analysis. I recommend or not the policy, or I recommend or not the market. But in the end, recommending the creation of a market is not the ultimate goal, but obtaining an estimate of the value for people of the service to see if the project passes a cost-benefit analysis. Yes?
My question is that you were saying that we should not go to the extent where everybody says no and where everybody says yes. So, but there is information there also, right? Because that is saying us the range of the price they are willing to pay. If everybody in the population started saying no, so we can conclude from that this is the amount they are on the edge. This is the range of the prices they are willing to pay.
Thank you. That's a very good point. If as part of your study, you come up with the totally yes and totally no, that is information for your design, right? When you are designing, you know that you should not be passing those values. But those are values. When I say those are don't go that way. What I mean is, do not include it in your discrete choice experiment or your contingent evaluation. But if you already know which are those values, the ones that give you the zeros and the 1, then you are lucky, because you know what values not to pass. But the important thing is that it should not be included in the discrete choice experiment. You already know what is the maximum and what is the minimum. Questions? Yes.
That 500 amount in this example, we can get it from existing literature also, or conducting a preliminary survey.
Exactly.
To get that idea. And one more thing, this willingness to pay or willingness to accept is going to be one of the attributes.
Yes. Thank you. That is a very good question that I have not addressed. By including the price, you are going to later on being able to calculate the willingness to pay. Because the willingness to pay is defined as the substitution rate between money and the other attributes. So we will see in the regression, you run a regression, you obtain a coefficient for green and for money. You divide the coefficient of green by the coefficient of money, and that gives you the marginal rate of substitution between green and money, but that is a willingness to pay. That is how much you are willing to give up money for green. That's what we call in economics willingness to pay. But I started with those two examples of the greening and the parking and everything, because willingness to pay is not only in terms of money. In that example, you were willing to pay with parking spaces or with facade space, because there we also are able to calculate marginal rate of substitution. So you always are going to have, I'm going to repeat what I said yesterday. A good discrete choice experiment is the one that presents you to trade-offs. So as long as one of those attributes is something that you will not happily give up, and one of those attributes is one that you really wish you had, there are trade-offs. And if there are trade-offs, you can calculate a willingness to pay in a unit that could be money, and most of the times is money because we are economists, but it could be parking spaces or facade space. How much of my facade space I am willing to give up for more green? Okay? That is the requirement to be able to calculate willingness to pay. That the discrete choice experiment presents trade-offs. When you do yours, make sure that you know that at least one of the attributes provokes this utility, that people hate it, that people don't want to give up money. And one of them is something that people wish with all their heart. People want green in that neighborhood, right? So that is a trade-off. If you have that, you will be able to calculate a willingness to pay, because a willingness to pay is nothing else but a marginal rate of substitution. Okay. What do you think? Did I explain a little bit better this curve this time? Yeah. Okay. And do you understand how a good discrete choice experiment should convince people that they are in a situation, they are being consulted in a situation that very likely is going to happen? That is called policy consequentiality. That the change is going to happen if most of the people are saying yes. There is another consequentiality, payment consequentiality. There is a lot of very technical literature out there that are discussing what is exactly this, what is not. And in this course, the only distinction I want to make is this. Policy consequentiality refers to whether people believe that if everyone or most of the people vote for the change or are willing to pay for the change is going to be considered to happen. So for instance, we have put a discrete choice experiment with a colleague of mine in 5 different countries in Europe, where we are telling them, please answer this discrete choice experiment that considers different ways of adapting to climate change, and it's going to cost you this much. We are asking you this because we were hired by the European Union government body to inform them of your preferences. And they will decide how to consider our inputs. So by the end, after the discrete choice experiment, remember I told you there is always a section where we ask questions. One important question that you need to ask is, how likely do you think that the results of this study are going to be considered by the policy makers in your country? That's what we are asking them. That's as much as we can get. Ideally, you want to push hard and say, answer truthfully, because the government, the European government body is totally going to rely on our opinion on what we say, because we are not allowed to say that, unfortunately. We cannot get to that point, right? But ideally, that's what you want. In the case of the Galapagos, let me show you that here. Let me show you how we did it. Remember, policy consequentiality, okay? I'm going to go to the other consequentiality. We want to know how much you are willing to contribute to fund enforcement of a conservation measure in Galapagos. Because the GNDP, which is the government body, is considering to increase the fee to everyone who is older than 18. If implemented, these extra funds will exclusively finance enforcement of conservation measures. And the last 2 parts are the parts that we claim involve policy consequentiality. The GNPD, which is the agency administering the Galapagos, has full authority to revise the entrance fee, which is what we are asking you for here. And also, they have the full authority to implement the conservation measures that I am describing here, right? And it happens to be that the information collected here will be analyzed by us in the Charles Darwin Foundation, who is the scientific advisor of the GNPD. So we are the ones who tell the scientific recommendation to the body that takes the decisions both of increasing the fee and of changing the conservation measures. And they are asking us to inform them because they want to see whether you want to contribute to the preservation measures through increasing fees. That's what we call policy consequentiality. To deliver the message that what we are doing is going to end up in the desk of the people who take the decisions. Why? Because we cannot tell them truthfully that whatever we say, it will go. We should have that power, but they don't let us say that. That is policy consequentiality. And basically, it means that in this world where everything is hypothetical, in this simulated market, if you don't make them believe that there is some chance that this translates into policy, they're going to throw you any number. Right? Any of us will say, yeah, sure, $5,000. Who is going to come and charge me? So that because you want to really get at the value, you need to convince them that there is a chance that this becomes a policy, and then next time that you visit Galapagos, you are going to be paying as much as we estimated. I don't know if you know, but just 3 months ago, the price in Galapagos went from $100 that they used to pay before our study, and now they are going to be paying $300 the entrance fee. I was suggesting 500, but they didn't want to listen to me. But I mean, it's always nice to see that there was an increase. So next time that they answer a survey like this, they will say, okay, I have to take it seriously. Okay, that is policy consequentiality. The other component is called payment consequentiality, and it is a little bit fuzzy, the difference. If you think about it, in this specific case, payment consequentiality and policy consequentiality is the same, because the policy in itself will mean that they will increase the fee, right? In other cases, it's less obvious, but using this as the case to differentiate policy and payment consequentiality, basically, policy consequentiality will be that the government body says now you have to pay 300. That will be policy consequentiality. And it does not tie perfectly to payment consequentiality. If someone thinks that it doesn't matter, they can always enter from the back door into the Galapagos. Right? For the specific case of the Galapagos, actually, that's not the case. They are very strict on who, when to enter. If you go through cruises and everything, the visa, everything, in Galapagos is very well counted who enters and who doesn't. So in that case, payment happens. If this was going to be done, for instance, in a natural park in Mexico, policy consequentiality is not the same as payment consequentiality, because there is always very bad monitoring of the park, and if they increase the price, there will be always some way to enter in this beautiful natural park from doors that no one knows. So, but that's the kind of, I like to use that as an example of payment and policy consequentiality. Okay? Sometimes the policy is not in itself the fees, but so again, you want a well-simulated market, and that involves that people believe that they will have to pay if the policy is implemented, and that their answers are going to be taken into account for that policy to be implemented. Payment consequentiality, policy consequentiality. One more term, one of those technical terms. Incentive compatibility. Incentive compatibility is related to endogeneity. You want people to be able to tell you the truth without choosing themselves, the value. So for instance, who of you tell me why is that I don't ask, instead of asking, are you willing to pay? Are you willing to pay 250? Are you willing to pay 500? Are you willing to pay 700? Why is that I don't ask directly? An open question. How much are you willing to pay? Why is that I don't ask you that? Because?
Because there is a benchmark in cost. We have
benchmark. That's one of the reasons. It could be one of the reasons, but there is one that is even more troublesome.
Because you have to incur the cost also. No? It's not necessarily like. It's not. If I ask somebody what is the willingness to pay without any benchmarking, you will not know only what's the context actually. He will say his answer based on his income levels, That will be many other factors which will be dependent on it. But if you take a benchmark and make him understand, okay, this is the amount you are contributing to conservation or something, and then you say the person, are you willing to pay 200 more or like 300 more? Then we can get a more accurate answer because they don't have a reference actually. That's what I think.
It is definitely one of the reasons, but the most troublesome one is tan 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 tan.
Maybe the person is not aware of what he is getting from the price he is paying. So if we say that we are trying to conserve this place and he might not be aware of the benefits, so maybe we are trying to convince him that the reward which he is getting should be incentive compatible to what he is paying. So yes, to make them understand that.
If at the moment that we are asking willingness to pay, the person still is not too aware of what she or he is getting, then we are doing a bad job. We have to be very good at the very beginning to establish what we are selling. Remember, we are simulating a market. We are going to have a scenario. We are going to be, so the government is considering this, and you will get this, and you will get that. Are you willing to pay this much? So at that moment, we are doing a bad job if the person doesn't understand.
I feel like here the value for money is a very personal thing. It might be like a household income plus priority question. So if you ask every household, they'll have different responsibilities, things that they're going to prioritize over this, and the cost that they will assign to it will also really differ then. I don't know what the economic term for something would be, but I think that's the phenomena here.
No, and actually it is true. It is good that it varies, and it is good that everyone has their own value. But here is the problem when I'm sure that you have gone to the market.
Pay will be very underestimated, right? No one will tell how much we are willing to pay.
That's the reason.
If someone asks me how much I'm willing to pay.
Here is the thing. You go to the market. That's the reason, right? Underestimation. And so think when you go to the market, and I forget how do you call it in English, but in Mexico we call it regateo. You go to the informal market and you say to the guy, how much is that pants? He's not going to tell you how much do you want to pay me for that pants, because how much are you want to pay for that pants? Whatever number you are willing to pay minus 100, 300, 500. When people are open, ask how much are you willing to pay, people are going to underestimate. We like to underestimate our willingness to pay as much as we like to overestimate our willingness to be compensated for something. So that's why we don't ask openly, because that question is not incentive compatible. You don't have the incentive to say the truth. Okay? Do not confuse policy consequentiality, payment consequentiality, and incentive compatibility. The incentive compatibility refers to whether you are in the conditions to reveal your willingness to pay from the question. That's why we came out asking people, are you willing to pay 50? Are you willing to pay 70? Are you willing to pay 100? It's called binary dichotomous choice question. Because the only option that you have in that moment is to say yes or no. You are not coming out with your own number. Sorry. You are not coming out with your own number. You are not deciding what to pay. You have the incentives to tell the truth, whether you are willing to pay that number or not. What do we lose? What I said before, the only thing that you can conclude is that the willingness to pay of people is higher, equal or higher, in the case that they say yes to 50, or lower than 50 if they say no. That's why someone came out here with what is called double dichotomous choice, which is once you say yes to that number, I ask you, are you willing to pay? And then I ask you for a higher number. So now I know that if you say yes, no, you are willing to pay more than 50, and if you say no to 70, and that you are willing to pay less than 70. So I am decreasing the range of potential values where your willingness to pay falls, and therefore I am gaining more information. Otherwise, I lose too much information by asking just one number. That is part of the contingent valuation study. If you think about it in a discrete choice experiment, implicitly, we are doing a double dichotomous choice question when we ask this. Because basically we are telling them, are you willing to pay something between 35 and 350? In this case, it's not completely perfectly clear, but you know, when these two or that one is the same value of the attribute and only you change this, you know, more or less that's what it means. Strictly speaking, at some point they will be facing one where both of them are the same, but the price, and then implicitly what you are asking is, are you willing to pay 30 or 350 if I present you to this? But then yesterday I explained you how actually we are eliminating those alternatives from this, because when you are presented to the same option but you can pay less, you are going to choose the one where you pay less, right? So strictly speaking, we could present it, but we don't present it in this scenarios because they are dominated. But implicitly, we are doing a double dichotomous choice question, like the contingent valuation. Okay. What else it has to do with design? Policy consequentiality, incentive compatibility, and policy and payment consequentiality. Okay, those are the questions that come after the survey, after the discrete choice experiment. I told you the one about how likely do you think that your opinion is going to be considered by the European Union government when taking this decision? That is for you to evaluate whether people think that there is policy consequentiality. And then the other one is, how likely do you think that this translates into an increase in taxes? That is to measure whether they think that there will be payment consequentiality. And people could believe that they will pull the policy without really increasing the taxes, for instance. So it's worth asking those two questions afterwards. The other questions that come after your discrete choice experiment relate to the attributes. If you think that there is one attribute that in particular is problematic, you could kind of test your respondent after that. For instance, I could always ask, how did you interpret the distance or time to your shared office? And then I can put alternatives where, two alternatives are the correct interpretation, or only one is the correct interpretation, and three are the incorrect interpretation. So if it turns out that they choose the incorrect interpretation, we will realize that they didn't understand us. And then you can say, oh, I probably should drop this person, or I could do something else. But it's important that you understand, that you realize whether they are understanding your choice set, your attributes. And the other two questions that come after is importance. Which one of the attributes was the most important for you? And which one of the attributes was the least important to you? Because in that way, you double check that you are including important attributes for most of the people. If 90% of the people tells you that the bike parking was not important, then you did something wrong. But if, for some people something is not going to be important for some people. So usually, to tell you the truth, in my experience, the one that comes as most important is the price, which is not surprising. And when it comes to the least important, actually, you need to have some variation. You want all of the attributes to be the least important for every, you want all the attributes to, a proportion of the people to say that one of the attributes is not as important, because they are not going to be equally important for everyone. And that's good. So those are the questions that come after the discrete choice experiment. 13 minutes to 5:30, so questions? Yes?
Somebody will take it. Okay. You need to.
Yeah.
Need your energy. Please conserve.
Yeah.
You.
I am going to, yeah.
I should probably have asked this question a bit earlier on, but I am having some difficulty understanding how we are estimating. So we have given these choice sets, right? And choice sets have alternatives to all of our respondents, right? So what we'll end up estimating with the logic would probably be like the probability of choosing an alternative I from a choice set, from like a particular choice set. But we are trying to isolate the impact of particular attributes, right? We are trying to give values to particular attributes. So how are we isolating that from the equation? I'm not understanding what the like y and what the x's are and how that plays into like the betas that we are estimating, or like the odds ratio or whatever, the marginal effects, whatever they are for particular attributes. How are we reaching to that?
I am going to be explaining with detail that tomorrow, and also actually tomorrow is going to be Charu. So yeah, for the sake of that, what I can answer right now is that have you run OLS? Okay, so imagine that you run an OLS where the dependent variable in this case is 0, 1. Yeah? It's not continuous, it's just 0, 1, which actually is possible. It's called probability linear model.
Most of us have run logics as well.
Okay. If you have a logit and you have a 0, 1, and then basically you explain that someone answers 1 based on the values of the attributes. So the explanatory variables are the attributes themselves. So for instance, imagine that this price, one of the attributes, the more the price increases, the less likely you choose that alternative with the higher price. Or the more distance you have to travel to your office, the less likely you choose it. So because these are attributes that are orthogonally designed, the coefficients associated with that change in probability, those are the ones that are going to give you a good idea of marginal effects. Now in the linear in the logics, the coefficients are not themselves marginal effects. Instead, we use them to calculate the marginal rate of substitution by dividing the coefficient of one by the one of the price. But if this was a linear probability model, or no less, you could interpret the coefficients as marginal effects.
So we end up getting those for particular attributes. So over here, the probability of choosing a particular alternative in a particular choice set also depends on like what are the alternatives available, right? So
yeah, exactly. That is part of the assumption. The assumption is that that you are going to give me a second. The model says you are going to choose from the available alternatives the one that gives you the most utility. So in that respect, is that depends on what is available in the choice set. But the important thing is that it does not depend on what is available in other choice sets. If it was somehow people was remembering, oh, but in 3 choice sets before this was available, and that enters in their decision, then definitely we are in problems. So when we present them, we ask them to choose from among the alternatives that are in the choice set. Because that is okay, that is because you are going to compare the utility that you get with one versus the other, and that's what you choose. So in that respect is that you are right. It depends on what is available, but only in the choice set.
I think probably probably they won't see Adan.
The regressions, right?
No, even before regression, the random mutation model. Utility, so 3 alternatives, utility from each, and when you're choosing one, that means that difference in utility.
Mm-hmm. Yeah.
That kind of.
Let me.
They haven't seen it before.
Yeah. Let me bring it. Yeah. When we take another question, and then I in the meanwhile, I upload.
Yes, sir. Here is online question from Subin from Nepal. Actually, he's asking question that I was attempting to review and study the impact of climate change to the migration from Hindu Kush Himalayan region, and was suffered by lack of proper previously done cross-sectional studies. I think applying DCE with climate stressor as attribute could be impactful. If there are any previous literature, please mention or suggest.
Let me see if I understand. Is a discrete choice experiment in the context of climate change adaptation?
Yeah. So let us repeat the question.
So it's from Himalayas, migration takes place in that context. Right?
Yeah. Yes.
Due to climate change, migration is taking place from Himalayas.
That one is that takes me to one case that we are trying to do in Mexico right now. I don't think that there are discrete choice experiments in the context of migration of people. But I should not be lying to you. My student is doing the literature review as we speak, so I'm meeting him tomorrow, so probably on Thursday I will tell you for real. But the way we want to do it in Mexico is we want to go to a community where people are, where youngsters consider migration with relative frequency, like due to climate change, but also due to almost cultural reasons, because in Mexico we have a lot of communities that have been migrating several decades already. Some of the males consider it almost as a, how do you call it, as a ceremony of passage. How do you say, like becoming older? So the discrete choice experiment that we try to put there, that we are just starting to do right now, says we'll try to measure how much will a teenager between 17 and 19, 20 will want to make in their future job in their state to not migrate to USA. You see what I'm going? Like we are going to be presenting types of contracts of jobs that are going to include expected payment, social security that only comes with formal sector or not, with formal sector, and also the sector. Do you want to work in the agricultural sector still? Do you want to work in the office, in an office? Do you want to work in the industry? And see with that how much is the average teenager expecting to make in exchange to not migrate. And one of the attributes is going to be how many more years do they want to study, or are they willing to study, if they are going to want to make that amount of money. But to the best of my knowledge, there is no discrete choice experiment trying to address migration. So there is definitely a research gap there, and it will be really interesting to address it.
You got it, he's right, you got it.
Yeah.
I think we are about to close, so maybe I'll...
Okay. I am going to be presenting tomorrow that equation so that we discuss the random utility model. But, not tomorrow, on Thursday. But, given that tomorrow you have the day, please take a look at the papers in the Google Drive. Part of Kenneth Train, the first and the second chapter. No one can explain better the random utility model than him. I read it when I was 21 and since then. So take a look at the chapter 1 and 2 of Kenneth Train. And if you don't find it in the Google Drive, he has his own webpage where he posted for free his book. Okay.
Yeah, no, I just, like, they're having such interesting conversations that it seems that we'll just go on and on. But I also wanted to draw your attention to, we said that we'll be forming groups, so just wanted to know what's the progress on that, and how many of the participants have thought about a research idea around which they want to design an experiment. I know some of them said that they are doing it, right? But I just want to know a little bit more. We thought that we'll be able to use some of today's time in discussing those, but you know, it just went on. But last couple of minutes I want to bring that to the table. So yeah, you're doing something, right? Yeah. What's your name? Pragya. Pragya is doing it, and I think from ICAR, Sulakshana said that she wanted to do online, but she is doing it. How about Bhavna? You're doing?
I had some idea. I discussed it with Swedish. I worked.
Yeah, so you know, some of you can join Bhavna, some can join Pragya, and yeah, few more ideas. Sanskriti, very good. Okay, yeah, and yeah, just yeah. What's your name? Where are you from?
SL, School of Languages, but I did my master's from political science from Jamia.
Okay, very good. So we already have about 5 and 6, maybe 3, 4 more, and then we're done. So last day we'll give you an opportunity. We'll give you the dice, and you know you can just present your idea, and you can also form one choice card with some illustration that these are the attributes we want, and these are the levels we're thinking about for a research question. It doesn't have to be perfect, right? It's a beginning, and just first step in designing your own experiment.
Thank you.
Yeah. Yeah, and attendance is very important because I'll have to report everything. So everybody has signed. If not, then please sign it now. I'll have to report and submit all these papers. Okay? And
yeah.
Anything else?
Try.
Tomorrow,
Yeah,
everybody knows that we're not having a session tomorrow, but we'll have a double session on Thursday. First session 10 to 1. And next session 2 to 5:30, and there'll be a lunch at 1.
So you have it already in written. I like that. I really like that.
The internet here is so bad.